Awesome.
So
Thank you.
last presentation then. This will be my presentation and Stephanie Becerra, and I wanted to read her bio, and then I'll bring up my slides here. So Stephanie. Hey, Stephanie. Hey. So Stephanie here. Stephanie Becerra is our development project manager. She graduated with a Bachelor's of Science in Environmental Science, Energy and Climate from Cal Poly Humboldt. With a strong passion for sustainability, her background includes completing a service term with the AmeriCorps as an urban forestry and drought specialist, interning with Grid Alternatives as a community outreach intern, promoting the installation of solar power systems in underserved communities, volunteering with the San Diego River Park Foundation and the San Diego River Garden. So, yay, Stephanie. Let me bring up my slides here. And Stephanie, your slides just, are sort of in the middle here, and because that's the way it flowed. And then, okay, hey everybody. So this presentation is about lowering utility bills and to some degree, like personal costs in rental housing, but it's mostly around utility bills. These are, lovely examples of projects that we'll be sourcing from in this presentation. My quick introduction. Hi, I'm Sean Armstrong. I'm a managing principal at Redwood Energy. In 1995, I came from Wisconsin to study at the Campus Center for Appropriate Technology, that demonstration house that you see there. And I met Michael Winkler, my partner, through that. Let's see here. I'm going to stop my video just to prevent any issues. Okay, so spent a couple of years as a high school science teacher, went into affordable housing, decided that was really my calling because I was passionate about both low-income households and equity, as well as renewable energy. And it felt like in affordable housing, there's a place that combined both those passions. And Michael and I started Redwood Energy back in 2011, and we've got a wonderful team that we get to work with, including Stephanie, since then. So I told you this is going to be about utility bills, and this is like a sideways version of that. The CPUC, Public Utilities Commission of California, they have a thing called the societal cost test. And this is one of 5 legally required tests that they're supposed to do whenever they raise rates on Californians, which is essentially what the CPUC does, is it raises rates over and over. We have the highest electricity and the highest gas rates in the country. Amazing, considering neighboring states have very low rates, and also like LADWP and SMUD, they have rates that are half the cost of the investor-owned utility. So this is very much a problem of governance. Now, right now, if you were to look at what would be the benefit, the net present benefit of single-family space heating electrification in 2020 dollars, this in blue, this is the electricity supply cost to serve the heat pump. All right, so that's what it costs to run it. And in just the standard TRC test that they do, which is not societal cost test, because this is supposed to compare, like these different tests do different things. So the one they do right now, TRC, which does not include the benefits to people's health, you can see that in yellow, the avoided natural gas means like right now, it'd already be cost effective to flip people over to electric space heating in California. That's what that first one shows you. But the middle one, that shows you when you add other values, like the societal cost of CO2. So that's climate change benefits. In green, you also see the climate change benefits essentially for methane avoidance. But look at blue. Blue is Nayeli Kobo, who presented as our keynote during the lunch. Blue is about what is the impacts on people's bodies, and therefore what are the medical costs. What would be the benefits, essentially, the avoided medical costs if you electrified space heating in California is what's showing you there. And this, the summary of this, this like 200-page report is basically like the benefits to Californians are huge, dramatically more than the cost of running a heat pump. And unfortunately, the CPUC has not yet implemented their own legally mandated societal cost impact. So they keep on doing everything with TRC over there on the left, not with the societal cost test in the middle, or in this case, the societal cost test with a high social cost test, basically saying like the avoided cost of CO2 can be amazingly beneficial because of, global warming. Now, I want to go into this issue of like, the cost to people's lives and their medical bills and their avoided, not getting to go to work, not getting to go to school. So gas stoves, they've been acknowledged to be dangerous since 1839. People know that gas stoves poison people. The industry's always known that they're just as toxic as secondhand cigarette smoke. And this has become sort of we had like a moment about this, like last week and the week before, where it was everywhere. The late night comedians, the headlines in all the papers, everyone's talking about the fact that gas stoves cost people the same health impact as living with a cigarette smoker who smokes in the house. And I wanted to illustrate this because this is data that we have that very few people have seen, which is we studied, was like 39 households here and studied when they're cooking on the stove, how much time are they using actually cooking with a fan on? We found that 14% of the total cooking was being done with a fan on. People would turn the fan on about 50% of the time, meaning like 50% of the cooking events. If they cooked it all, they used a fan, an exhaust fan, half of the time. But half of the instances, I should say. But of the total amount of time cooking, it was only 14%. And they actually have a hood that exhausts, one of those rare things in California, but people don't use them frequently because they're so noisy. And this, once again, really incentivizes us to convert to electric cooking, which reduces the amount of air pollution in a kitchen by 4/5. It's radical. And you still get air pollution from cooking on electricity because you burn the oils, like cooking oil. And any oil that burns, regardless if it's a fossil fuel oil or a natural oil, they produce a lot of the same pollutants in your house, but fossil fuels are worse. There's lots more pollution, but nonetheless, cooking on electricity, you want to ventilate. And we just have this problem in our country is that in apartments, rental housing, very few people have access to exhaust hoods. They're frequently really noisy to operate and they have very low capture efficiency and people don't use them very much. We don't have even a culture around the idea that you should always turn on the hood. Okay, so I wanted to say like, hey, let's just start off with the fact that it would cost people in their health, the most important thing, it would cost a lot less in rental housing if we converted the stoves particularly. But all gas use, the space heating, the water heating, all of them, it would cost people this dramatic decrease in medical costs. Okay, sort of back into the energy realm a little bit more. The Energy Commission hired us. We got to work for 4 years with some of the wonderful people at AEA and Stone Energy Associates and Franklin Energy. And so all these great people we discovered. On the top, you can see in orange, this is electric resistance energy that's being used. And in blue, this is the heat pump for a water heater. This is real data. And said like, this is how if you just open it up out of the box and you plug it in, this is how the water heater is going to operate with its typical settings of hybrid mode, water temperature at 125. If you go down below, you can see we installed 62 of these tanks with thermal mixing valves, which allowed us to safely set the water up to 140 Fahrenheit. So that's hot enough to scald someone's skin. But thermal mixing valves means that it's still delivered at 125 and it's safe. But it basically is like a thermal battery, which is something that my partner, Michael Winkler, really brought to our relationship at the very beginning, was helping me think about how we can use heat batteries as opposed to electrochemical batteries to lower the cost of energy storage. And in this case, we also provided better service. People could take more showers this way, where we raised the water to 140 Fahrenheit, turned off the electric resistance, and then ran it only in heat pump mode. They got more showers and it used 30% less electricity. And that's particularly the kind of electricity that's a real punch to the grid. It's very high power demand, so it ends up being worse for the grid than almost any other thing is the heat pump water heater's electric resistance elements. So the way to think about that is that an electric resistance element uses about 4,500 watts and the heat pump uses like 450. So it's about a 9/10 reduction in the amount of instantaneous power that the heat pump, that a hybrid heat pump water heater demands if you put it into heat pump mode. So it's a great benefit to the grid and reduces energy consumption. So this data helped inform what we now have is 120 volt heat pump water heaters like this picture has, and you can see the extension cord like that's just plugs into any outlet. And that that little black attachment there, those are thermal mixing valves inside that black thing. Okay, this is another thing that we found from that State of California funded research was, we designed these apartments to be almost passive house, like what Shane Poland spoke about a little bit earlier. So what we saw is that people weren't turning on their heating or cooling more than 1 day out of 7, like basically just like, just on the weekend or every once in a while. People rarely were using their heating and cooling systems throughout the apartment complex because it was designed to Energy Star for Home standards and LEED Platinum, and it was just really energy efficient. But there was once again a problem with electric resistance backup of sorts. All these super efficient heat pumps that were installed had a crankcase heater, which is literally just an electric resistance heater around the compressor. So in blue, that's the electric resistance that's being used on an average day in the summer. So some of these places not even using air conditioning in the summer. And the orange is the cooling energy. And then below that, that's in the wintertime. Once again, the electric resistance element is the majority of the energy. And then in both spring and fall on the bottom, you can see almost no orange heat pump being used. It's just this stupid electric resistance element that is supposed to, it's particular to certain designs of heat pumps even. Most of them don't have to have this. The electricity keeps the lubricating fluid at a certain viscosity so that it doesn't mix with refrigerant that might leak. It's just a very specific technical thing, and it wastes energy day and night. And this is a problem. And then one of the worst parts of it is that specification sheets and software don't explain how much energy the crankcase heater is going to use or how it's controlled, because some of them turn on and off and some are on all the time, like this one was. So the upshot of it is that at this apartment complex, heating and cooling was like 70% the stupid crankcase heater and about 30% what was actually being asked for overall in the year. Really terrible. So reducing utility bills would be like dealing with that. Now, next thing. This is my old boss, Chris Drought, and he's explaining some of the issues of why you do solar. So all electric is less expensive. The cost of bringing gas to a building site is expensive. In our developments, all electric is less expensive to build and just as efficient or more efficient in operations, and you can't generate gas on site, but you can generate electricity with solar electric panels to lower bills. I was just showing you two of the most inefficient parts of an apartment complex that we studied that was supposed to be super efficient. So either those efficiency options, if they had been, if they'd been implemented, and we did get all the crankcase heaters fixed, and we did set up all the water heaters when we left to be heat pump water heaters. And all of that could have shaved off a significant amount of energy, off that apartment complex, but you still, energy efficiency generally doesn't get you more than 20 or 30% of the apartment's demand. So adding solar is what you need to do at some point. And I want to show you how big of a deal this is to add solar. So we designed the tribal housing, replace a trailer home park with permanently built elder housing in the Hoopa Reservation nearby, about an hour away, hour and a half. After we'd made the building super energy efficient, quality installed insulation, done all the HERS measures, done all the Energy Star appliances, chosen really energy efficient mechanical systems. After all of that, you can see here that in the left-hand side, propane plus electricity, assuming that we're using 93% efficient furnace and water heaters, the electricity bill will be $28, propane is $51, and the total bill is $79. If we do all electric, it's $59, no propane bill. So just that, efficient all electric, and not super efficient, just reasonably efficient, $59. And then if you add solar, $5. And this is a great example of like efficiency gets you so far, and then you need to put solar on to lower people's utility bills. And I feel like this is a very core insight of our consultancy, because we've been swimming upriver this entire time with people who advocated for an energy efficiency only and wouldn't even talk about fuel switching and would not talk about adding solar to the roof. They're just committed to energy efficiency, which does not lower bills very much. And so on behalf of like tenants and renters, I want to say that energy efficiency has significant limitations structurally, and we need to rethink some of our language around adding solar, because that works. It works dramatically, like what you're seeing here. Now, Stephanie, this is your turn, and I will forward your slides for you.
Okay, I'm just unmuting. Okay, so I'm going to cover the study that we did on changes in monthly utility allowances for electric and gas developments that were using the QAC, so California Utility Allowance Calculator, as discussed previously by Maria and Michael. This study was over the last 4 years. The original analysis consisted of 15 projects, 5 from each of the major utility companies in the state. But for today, we'll just be focusing on 1 project from each state. So the way it works is once you get your QAC approved, you have to resubmit an annual QAC for TCAC's review and approval based off the utility tariff lookup tables that are also updated every year. So in 2022, there were 2 utility tariff updates to the QAC tool. So this means that in 1 year, the utility tariffs changed twice. The increase was so significant that a lot of clients started to reach out, very concerned of what could be going on. They thought that maybe there was an error, we did something wrong. So I went back, I started looking at a bunch of reports. Nothing had changed, not the energy loads, not the solar array, not the percent of solar allocated to the tenants. The only thing that had changed was the table versions of the utility tariff lookup tables. So for the first example project in PG&E territory, this is a 74-unit multifamily low-rise development with a 31.4% solar offset of residential loads. So over the last 4 years in the electric rates, we see an increase of 33% on average for all 3-bedroom types. And for gas, we saw a gas rate increase of 50% over the last few years, which is pretty significant. And this is why our clients were reaching out, like, what's going on? Next slide, please, Sean. So the second example project is SoCal Edison territory. This is a 62-unit multifamily low-rise development with a 40.5% solar offset of residential loads. And even with that much percent solar offset of residential loads, there was still a 74% increase over the last 4 years for electric rates for all 3-bedroom types on average. And for gas, there was a 26% increase over 4 years on average for the 3-bedroom types. Last project, our third example, an SDG&E territory. This is a project that consisted of 200 units, multifamily low-rise development with the 50% solar offset of residential loads. So each example, the solar offset of residential loads kept increasing, but so did the increase in the utility rates, regardless of having that much solar on. So for the 3-bedroom types, there was an average of a 74% increase over the last 4 years for electric rate, and for gas, an 85% increase over the last 4 years. And I live in San Diego right now, and I know firsthand about the increase in utility rates. We have some of the highest rates in the country, and 1 in 4 San Diego residents can't pay their utility rates right now. Next slide, please. So what we found was that properties that were all electric and provided 100% of solar offset for residential loads were protected from these high increases in the utility tariffs. So over the last 4 years, for an all-electric 100% Z&E development, there was only an increase of 1.3% in utility rates. So 13 cents compared to some of our other example projects where the increases were up to $30. And for other example projects that we had that I didn't display, some of the rate increases over the last 4 years was almost $60. So as mentioned by Sean, Michael, Maria, the amount of rent you're able to recoup based on the utility allowance has a huge effect when it's changing by 10, 20, 30, 40, 50, $60 every year. Multiply that from anywhere to 70 to 200 units. It's very significant. There was another study that we did where we compared a bunch of projects that were all electric, 100% C&E, monthly minimum rate of $10. Compared that to the monthly housing authority utility allowance and saw what the rent revenue was over a year. So for a 79 unit project, it was $50,000, and over 15 years, that rent revenue was almost $800,000. So not only does it add benefit for the owner, there's a lot of benefit to the tenant, security, peace of mind. I mean, I would love to have a $10 monthly utility bill every single month and know that that's something that I can feel secure about. It's not going to change. I'm not going to have to be adjusting my budget every single month for an unknown, spike in my utility bill. And that's everything I have for you guys. Thank you.
Thank you, Stephanie. So this issue of like how does solar benefit tenants that Stephanie was just speaking to, and emphasizing that 100% offset is a very significant difference than even like a 60 or 70% because it eliminates bills. Pardon me for a second. I'm presenting. I can't have you in here right now. Sorry. All right. Sorry about that. So Sacramento Municipal Utility District, they just this year unveiled a program to allow solar panels on apartment complexes to be divided up at the building department, so you don't have to directly wire. So in orange here, you can see what a tenant's utility bills would be for 1 bedroom, 2 bedroom, 3 bedroom. That's with no solar. This is just a highly energy efficient apartment. It's called, we're calling 8th and R. It's just this intersection in downtown Sacramento. And you can see the building there. And it's low income housing. It's a beautiful spot. Now, in blue, this is what we have negotiated to, because the first iteration of this program a couple months ago, it paid a lot less. And so you can see how the utility bill has dropped from orange. This is because you're adding essentially a zero net energy solar array, but you're still having a utility bill. Like it's still in that $30, $40 kind of range. In yellow, that's what you get with the same solar array if you're a single family house. Catch that? The rates that are paid to apartment complex people with their own personal solar array are lower than are paid to single family homes. And it was almost twice as bad of a gap before they reformed it over our protest with like 4 or 5 other affordable housing developers who just outraged at the idea that the solar is worth less when it was on an apartment complex serving low-income households. Because keep in mind, that blue rate that you're seeing there, that is only for low-income households. It is only for affordable housing. It's not even for like all market rate apartment complexes. They still don't get service and help from SMUD. You cannot do a solar array on most apartment complexes in SMUD territory. And we just showed you how important and financially beneficial it is. In green, this is a whole another rate. If you're in an apartment complex, same solar array, but you're officially poor enough that you get their discounted rate, then you get down to $12, $13. They call it EPR. It's called CARE in the rest of the state, the EPR rate, the CARE rate, whatever. But I want you to see that both, like, it's important that you put solar on apartment complexes to cut people's bills, but it's also important to pay attention to the policies, because SMUD is not paying apartment complex residents, low income ones no less, as much as they are people who live in single family homes. Just straight up, it's a brand new policy. They did it on purpose. And this is as good as we've gotten it after flipping out on them. A whole bunch of us saying, how could you possibly be so unfair? There's literally no justification. This is a less expensive system for you. Like, what we're putting in makes it easier because it's all coordinated and such. It's not a whole bunch of individual homes. How can you possibly justify? And it can't be justified, by the way. There isn't a response to why would we do that? All they came back with was, well, we hear you, and so we think that solar is more valuable now that we've had a drought and our hydro dams aren't putting out as much electricity. So now apartment complexes, we'll give you that blue line, where we're still not going to give you the yellow one. No, that's where we are right now. Okay, so here I also wanted to illustrate how if you add more solar to tenants, how it can lower the construction cost of the project because it avoids batteries. So Sean Neiman, he just showed you how to do trellis solar, or I also call it canopy solar, where you elevate it above things. And you have, or you could put solar on the walls. Now, on the left-hand side, you can see this is like bids from Cal Solar for this project. Prescriptive code is $580,000. That meant that there was 119 kilowatt hours of batteries, those Yada batteries that were just discussed, and then there was 104 kilowatts of solar on this 5-story building. And that's just what the software spits out. It's like the prescriptive code. And generally that's what you'd see people do. We started experimenting with it because at $5,600 a kilowatt of solar, that's including the battery cost in with the solar, to go like, okay, usually we would put 104 kilowatts of solar. Now with batteries, it's 5,600 a kilowatt. Versus if you can put the solar on the roof, but on a canopy. And this is assuming too low of a price. Well, what it is, it's assuming $2,400 for everything that's on just the normal part of the roof. And then it's assuming about 20% of the solar array is a higher $4,500 a kilowatt price because it's a canopy. So a blended price of $3,200 a kilowatt here. But this is where instead of putting 104 kilowatts of solar on the roof and then putting 119 kilowatts of battery, you'd put in 20% more solar. So 126 kilowatt, not 104, 20% more solar, and no battery requirement. And that's how the software works. And so instead of it being 580,000, it's 403,000. And all that extra solar goes and lowers tenants' utility bills, whereas the battery does not. All those extra batteries are not for lowering tenant utility bills. I want to show you this, that this is not just me like imagining this. These developments are many years old now. Over in Philadelphia, Onion Flats, 3 brothers, one's an architect, one's an engineer. One's an architect, one's a general contractor, and one is the realtor. So together they design, build, and sell. So you can see on the left-hand side, this is a big canopy solar array over a 4-story tall zero net energy building. Those colored panels are supposed to show how individual apartments are using energy, and they're anonymized, but you can figure out which one's yours. So outside, you can sort of get a sense of how green or orange or red is the consumption going in that building. Kind of fun. On the right-hand side, this is pretty exceptional. It's three sides of this 4-story tall building, which is 4 stories over commercial on the 5th floor down below. And it has a canopy solar up on the roof that has gardens growing grass underneath it, because solar panels can let light through if you just have what's called bifacial panels. And you can see those on the left-hand side. They can let dappled light come through. And the pricing for these buildings, 169 a square foot and 157 a square foot. I'm just showing you, those are crazy low prices. Even at the time when they was being built, those are crazy low prices. And look what they were doing. You heard $2,400 a kilowatt for solar. Because this is all internal, they're doing it all themselves. They installed for $1,500 a kilowatt, including everything on the walls that you're looking at there. So essentially, they just installed for themselves at cost, and they saw, oh, it's not that expensive to put it on the walls. Another thing, how to lower tenants' utility bills. So this is coming at us, which is the ability to sell electricity into the grid from your electric car. Like Ford, the F-150 Lightning is just starting to figure out how to do that. But Ford and Chevy, they've agreed as of a couple weeks ago that they were going to collaborate to make their electric vehicles be able to feed into the grid, just like Nissan has been doing since 2011 or 12 or so over in Japan. So this is a thing that's been in Japan since the tsunami, which shut down all the nuclear power plants in the country. And so Nissan unveiled their vehicle to building chargers. And so I want you to see here from left to right. Let's just say that you're spending a certain amount of money, like $800 on utilities. And then you add in all your gas costs for driving your internal combustion vehicle around, because that can be more expensive than the house. Well, let's say if that you were turn it into an EV and you just charged it hard whenever you wanted to, that would raise costs. This, by the way, is a study that we did for Redwood Coast Energy Authority, our area here, our utility rates and such. And so then what if you did smart charging, just don't use electricity at the wrong time? Okay, then that'd be less expensive than driving an internal combustion engine around because you timed it right. What if you use that electric vehicle to offset in the moment that you're using loads in your house, like just offset your house's energy, charge, like running your house off your car? Okay, even lower bills. But what if during those moments when electricity is incredibly valuable to the grid, like 10 or 30 times more expensive than normal, what if you sold a little bit of electricity into the grid then? You can lower and eliminate your entire house and vehicle utility bills if you have the ability to charge into the grid at least 20 amps at 240 volts. And this can get into equity because if rental housing doesn't have the ability for people to charge into the grid and single family homes do, once you get into like the haves and the have-nots, people who have the power literally get the money, have the electrical power to sell in. So this is important in apartment complex design, that people have the ability to sell their electricity into the grid and get proper credit for it. And that frequently would mean that you would wire a parking space directly up to their apartment, which we're doing for the first time with like 100 parking spaces in a Habitat for Humanity development, directly wiring. And that way they can offset their home's energy consumption or even sell into their personal meter. So it's coming at us. Just want you to know, this is how you can really, really get rid of bills. Right up there with PV is selling your car electricity. Now, you think I'm just dreaming? Well, Utrecht, Netherlands, already has 1,000 of these public vehicle to grid chargers in place today. They say they need about 10,000 EVs plugged into their grid of over 140,000 people in the city in order for them to become a bi-directional city, where the whole city is being sustained with solar and wind during the day, and people's vehicles are plugging into their grid at night, and they're doing grid balancing, and they're going for it. They think they're going to have this done in the next 5 to 6 years, and they're installing them like crazy all over the city. And this is a literally lovely example. This is the world's largest parking lot that charges the grid. So it's got this bifacial solar panels. You can see if you look up this fellow, he's a real famous guy in the EV world, tons and tons of YouTube videos. So this video he's showing here is like, he's an electric vehicle and it's lit underneath the solar array because sun can come through the panels if you just take the plastic layer off. And then all the parking spaces have these vehicle to grid chargers so the EVs can come in and help out. And they soak up the sun during the day and they sell it at night. This is where we're going. And here's what's available today-ish. On the left-hand side, Wallbox and actually Wallbox and Nuvei have partnered up to sell the Quasar. Asiaco is coming out of Canada with the Decibel. We're getting to do the first installation in North America of those in a house in Oakland this spring when it comes out. Nuvei has already been selling ones for buses and fleets of vehicles, essentially like a fleet vehicle to grid charger that you could sell into. And Fermata Energy, ignore that because it should say Enphase. I just didn't have a chance to do the edit. Enphase yesterday just announced that they were releasing a vehicle to grid charger. And Enphase is one of our nation's largest like sort of solar panel inverter combination companies. And essentially they're a market leader in single family homes. So it's a big deal that Enphase has just come out with something that works with their solar arrays and their batteries. That's now like a vehicle to grid inverter. It's very similar to what Asiaco is offering, which is also a solar inverter plus the vehicle to grid chargers, unlike Wallboxes on the left and Nuvei's to the right there, which both of those are just the vehicle into the grid, but they're not managing solar. So it's happening. And that is the end of my presentation. I wanted to show you like, how do you lower tenant utility bills? What we're seeing is that you add solar. and you get rid of the fossil fuels in their homes because their utility costs are dwarfed by their health costs of having gas in homes. So, yay, we did it!